We're going to do a bit of revision work on equation of a straight line. I'm going to do pairs of examples here. So the worked example I am just going to talk through, and it may be a good idea if you pause the video at the your turn bit and have a go at doing these your turn ones for yourself. I've got an equation, y equals 5x plus 2. I've been asked first to find the gradient. The gradient can be found from the equation of a straight line in this format by looking at the coefficient of x. The coefficient of x is 5 here. So our gradient, which I use the letter m to represent, is 5. The y-intercept can also be pulled from the equation in this format. The y-intercept is the point where this line crosses the y-axis. Because it's a point on the y-axis, it will have a coordinate 0 something. That something is going to be positive 2. Now, the whole point in the equation of a straight line is it can be used to generate y coordinates. If I plug an x value in and evaluate the right-hand side, i.e. do the number work, I'll get the y coordinate out. So when x equals 0, y will equal 5 times 0 plus 2. 5 times 0 is 0, plus 2 gives me 2. What we've essentially done here is we have calculated our y-intercept. When x is 0, y is 2. Right, the next one. When x is 1, y equals. So again, this is just a case of substituting the 1 in for the x and doing the number work. 5 times 1 is 5, plus 2 will give us 7. So this is another point that is on the line. The point 1, 7 lies on the line. When x equals 2, y equals, well, same deal. We take our equation and we plug 2 in where we had x. 5 2s are 10, plus 2 is 12. That would give us 2, 12 as another coordinate. The whole point in the gradient, a gradient of 5, is for every one step along we take, we go up 5 in the y direction. If you look at these 3 values here, the x has increased by 1 each time, the y has increased by 5. So our gradient is at play here in these y coordinates. The next bit asks us for a parallel line. There are an infinite number of answers for this bit, but if lines are parallel, they have equal gradient. They've got the same steepness. So my parallel line is going to be y equals 5x. The 5 needs to be there because the gradient of this parallel line is going to be the same as this gradient up here. The y-intercept could be anything, so I could write plus 3, and that would be right. I could write minus 3, and that would be right. All that I'm changing here is where it crosses the y-intercept, the y-axis even. That is still a parallel line. My constant, my y-intercept at the end, isn't going to affect whether or not it's parallel to this. The gradient is the thing that is affecting it. The next one here, there is only one answer. We're looking for a line which is parallel and goes through 0, 7. Y equals 5x. I know that has to be true because parallel lines have equal gradient. The coefficient of x needs to be 5. 0, 7 is a point on the y-axis. 0, 7 is my y-intercept. So plus 7 is how I would complete that equation. The value of x when y equals 0. This is similar to these three questions here. I know one of the values, I can plug it in and work out the other. So y equals 0. Y is 0 equals 5x plus 2. I've now got a little equation I can solve. I can subtract 2 from each side, and then I can divide each side by 5. That will give me x equals negative 2 over 5. If I want, I can think about that as a coordinate. Negative 2 over 5, 0. So I've got the x value, and I've interpreted it as a coordinate. Right, the your turn. You can pause the video here and have a go at that. I will fill in these answers fairly quickly when you replay. Right, hopefully you've had a go at these. This one, coefficient of x is 5, so my gradient is still 5. My y-intercept, I've got this plus 15 at the end, so my y-intercept is going to be 0, 15. When x equals 0, y equals. I could plug in a 0 and do the number work. However, this is just another way of asking what the y-intercept is. When x is 0, y is 15. When x is 1, need to do a little bit of number work here. 5 times 1 plus 15, that's 20. That gives me the coordinate 120. When x is 2, y equals 5 2s plus 15, 10 plus 15, 25. Again, I can interpret that as a coordinate 2, 25. The gradient of 5, increase of 1 in the x, increase of 5 in the y's. So the gradient of 5 is still in play in this bit here, same as it was over here. A parallel line. So long as you have got y equals 5x, your y-intercept can be anything you want, so long as it's not plus 15. So you could have plus 16, you could have minus 16, you could have what y had in the first one. You could have y equals 5x plus 2. Parallel which goes through 0, 7. Y equals 5x. This is a y-intercept along 0 up 7. We're in this situation here with this point. So it means I need a plus 7. These two lines are the same because these two lines have the same gradient. The value of x when y equals 0. I'm going to plug a 0 in for y, and I'm going to figure out what x is by solving the equation. So I take away 15 from each side. Minus 15 equals 5x. I then have to divide each side by 5 to get x equals negative 3. I can interpret that as a coordinate if I want. Negative 3, 0. Here's another worked example, your turn pair. You might want to listen and work through these with me, or if you're feeling happy enough, you might want to skip on to the actual task. There's a timestamp in the description of this video that will take you straight to an explanation of what the task is. Right, first one. Y equals 3x plus 6. Here we can pull the gradient and y-intercept out really easily because our line is in this y equals format. So our gradient m is the coefficient of x, which is 3. Our y-intercept, the point the line crosses the y-axis, will be at 0 because our y-intercept always has a x-coordinate of 0, 6, so positive 6. When x equals 0, y equals 6. There is no need to do any number work. There is no need to plug the 0 in because this is another way of asking you what is the y-intercept. X is 0, y is 6. When x equals 1, we should really plug in our numbers here. 3 lots of 1 plus 6. 3 ones are 3 plus 6 is 9, which could be expressed as a coordinate 1, 9. When x equals 2, y equals, so again it's asking us to plug 2 in for the value of x, so I'll have 3 times 2 plus 6. 6 plus 6 is 12. Again, we could interpret that as a coordinate, x coordinate of 2, y coordinate of 12. Again, gradient of 3, every step up of 1 our x coordinate has taken has resulted in a step of 3 in our y. A parallel line. So a parallel line needs to have the same gradient as the one we've started with. So y equals 3x plus or minus anything we want here. Other than plus 6, because that would be the same line. So plus 5 or minus 5 or 3x on its own. All of those and any variations of them will be parallel. But the 3 needs to be there. Parallel, which goes through 0, 7. So it's a parallel line, so my gradient is still 3. The coefficient of x has to be 3. 0, 7, again this is a y-intercept here, because the point 0, 7 is along 0 up 7 on our y-axis. So that means the equation of this line will be y equals 3x plus 7. The value of x when y equals 0, so this is using our original equation. If I swap y for 0, I'll have 0 equals 3x plus 6. I can subtract 6 from each side. I can divide each side by 3. Gives me x equals negative 2. So that's the value of x, but remember we could interpret that as a coordinate. Next one, if you want, you can pause the video here and have a crack at it yourself. So, if you had a go at it yourself, here go the actual answers. Gradient, nice and straightforward. Gradient is 6. So here, the 6 and 3 have actually swapped places in the two equations. The y-intercept, that'll also changed. That's now 3. When x equals 0, y equals 3. Just reading that from our y-intercept, we could just read it from our equation. If we forget though, we know we can plug a 0 in here, and we would get a 3 when we do the number work. When x equals 1, I'll have y equals 6 times 1 plus 3, which will give me 9, which I could, if I wanted to, interpret as the coordinate 1, 9. X is 1, y is 9. When x is 2, y will equal 6 times 2 plus 3, which will be 15. The coordinate 2, 15 will be on my line. My gradient is 6, So as my x is increased by 1, my y is increased by 6. A parallel line will be any line that has a gradient of 6. So y equals 6x, and so long as we don't have plus 3 at the end here, it's fine. If you have plus 3, it's the same line, it's not parallel. A parallel line which goes through 0, 7, that'll be y equals 6x plus 7, because that 0, 7 is a y-intercept. The value of x when y equals 0, the fact the 6 and 3 are in a different place means that this answer here is going to change. So I'm going to make y equals 0, and I'm left with 6x plus 3 on the right. I will subtract 3 from each side, and then divide each side by 6. So that will give me x equals negative 3 over 6 goes to 1/2, which I could, if I wanted to, interpret as the coordinate negative 1/2, 0. Right, the task. The task is going to be presented like this. If you have access to a printer, you might want to print it out. Otherwise, you might want to just set it out like the example question pairs were on the previous 2 slides. The first one gives you an equation and wants you to find all the information. The rest of the task, though, involves you having to sort of work back. So all of these boxes are going to be connected. I have not put full solutions up on your Google Classroom, but what I will have is I will have hints for this first page. The second page is set up the same way as the first page with some slightly different numbers. So just take care when you are working with this.